सेकेंड टाइप ऑफ इंटेग्रिटी इज रेफरेंशियल इंटेग्रिटी. ठीक है, इसके नाम से जाहिर है this constraint is basically related to the referential thing. And what is that? That is the reference thing, the primary key and the foreign key relationship thing, right? So referential integrity means that ever if there is a value in a foreign key, okay, if there is a value in a foreign key and that value is not matching with a value of primary key from the parent relation, then referential integrity would be broken. If there is a null value, there is no need to match because null value is a legal value for a foreign key. But if there is no null, if there is a value in the foreign key, and if that value is not matching with a value in the primary key of the parent relation, then the referential integrity would be broken. Okay, so this is referential integrity. Now we can apply 4 type of operations on the data that is stored in database. They are commonly known as CRUD operations, C-R-U-D. You might have listened this word. You might have heard this name. So C is for creation, R is for retrieval, U is for updation, and D is for deletion. Okay, so these 4 things can be done on the data that is stored in a database. Creation means adding a new instance, adding a new row in a relation. Okay, so C represents the addition of a new row in a relation. Okay, R means retrieval, reading of the data from a relation or multiple relations. Okay, U means update, editing, changing the already existing contents of row or rows in a relation or relations. And finally, D is to represent deletion. Deletion means permanently removing a row or multiple rows from a relation or from relations. This R operation is a safe operation. It's a safe operation because it's a read-only operation. It has nothing to do with the data. It has nothing to do with the contents. So there is no threat to referential integrity. We are talking about referential integrity. So R के पास कोई threat नहीं है for referential integrity. Second thing is creation, adding a new instance. So whenever we are adding a new instance on the parent side, if we are adding an instance on the parent side, seems safe, right? Seems safe because we are not doing anything with the foreign key. But whenever we are adding a new row on the dependent side, then we need to be careful. We need to be careful that an irrelevant value is not added. The range for the cell would be the values of the parent side's primary key. So at the time of creation, we need to be careful that the value that is assigned to foreign key, that value should match with the value of the dependent side's parent side's primary key. Secondly, updation. If we are updating on this side, there is no threat because primary key's value cannot be updated, that cannot be changed. So if we are changing something, there is no threat to referential integrity. But for example, if we are updating on the dependent side, then again we need to be careful. If that update operation has a change request in the foreign key's value, again we need to be careful. We need to check if the new value that is replacing, for example, an old value of the foreign key, that value should match with the value of the parent side's primary key. And finally, we have this deletion operation. If we are deleting something from the dependent side, there is no dependency. That operation would be safe. There is no threat to referential integrity. But if we are deleting some row or rows from the parent side, then yes, there is a threat to referential integrity. And what is that? For example, a row is deleted and there are some matching values with the value in that primary key, then the referential integrity would be broken. So we have to do something. So in order to control this thing, we have three different rules that we can apply depending upon the scenario. It is dependent on the scenario. Scenario would tell us that which deletion rule is to be applied. So there are three deletion rules. The first deletion rule is known as a restrict deletion rule. A restrict deletion rule is that if there is a primary key and foreign key relationship, and if you want to delete a row from the parent side, your DBMS would not let you delete that row. Okay? If you intend to delete a row in the parent relation, you will be restricted if that row's primary key has a match in the dependent side, on the dependent side's foreign key. So in this particular case, you can delete this row with CID 2. Your DBMS would let you delete this row, but you would not be able to delete this row. जब भी आप इस रो को डिलीट करने की कोशिश करेंगे, you would be restricted by the database management system. If you have applied the restrict deletion rule on this particular relationship. So these rules are applied on the relationships because primary key and foreign key, they are for one particular relationship. So for this particular relationship, if you have applied a restricted delete rule, you would not be able to delete a parent relations row if there is a match of that primary key value with the dependent side's foreign key for this particular relationship. समझ आ रही है बात की? This is restrict rule of deletion. Second rule is known as a set to null rule. If you apply a set to null rule to basically control your referential integrity, then whenever you intend to delete a row or rows on the parent side, and if that row has a match on the dependent side, that row would be deleted, but your dependent side relations foreign key values, they will be set to null. Okay, for example, in this particular case, if you delete this row, for example, this row is deleted from here, this row would stay, but this one value would be changed to a null value. This is set to null. What has happened? The instance of the parent side has been deleted, the relationship instance has been deleted, but the dependent side instance is there. Okay, so you have basically controlled the referential integrity, but the relationship instance has been broken. So it depends on the scenario that you apply a restriction rule or you apply a set to null rule. You can apply a set to null rule if there is a zero minimum cardinality, right? If there is a zero minimum cardinality on the parent side, it would mean that you can apply a set to null deletion rule because null value would be permitted on the other side. Okay, and if there is, for example, a mandatory cardinality on this side, then you may apply the restrict rule. There is a third rule as well, and that rule is known as a cascaded delete. Okay, a cascaded delete, if you apply a cascaded delete, and for example, a row from the parent relation is to be deleted that has a matching row or rows on the dependent side, then whenever you delete that row, the dependent side rows with matching values, they'll also be deleted. Yes, all of the matching rows, they'll be deleted. It depends on the scenario. Where we can apply this scenario? Where we can apply this scenario? For example, that is a weak entity. For example, that is a weak entity. It means that those rows, they are dependent on these rows. So if ever these rows are deleted, those rows are also be deleted. So if there is, for example, a weak entity, we can apply the cascaded delete rule. There can be other scenarios as well, but this is one of the examples, the weak entity case.